how to read the data sheet of the solar panel for best panel selection. So basically, whenever we are choosing the solar panel for designing of the solar home system, it is quite important actually how we are selecting the solar panels. What are the important points has been available from the data sheet actually? What point we have to note down for the further designing of the solar home systems? So with the help of the data sheet actually, we are going to see what parameter we can just able to see actually whenever we are selecting the any kinds of the solar panel. So let's say in this case, I have selected the monocrystalline type of the solar panel and which is having the Trina company over here actually. So any manufacturer you can choose the solar panel, but only thing is that you have to choose the some amount of this parameter one by one over here. So the first parameter is that we have to look at into the data sheet over here actually. So in this data sheet, so here actually from the 340 watt peak of the solar panel up to 375 watt peak of the solar panel, the various ranges of the solar panels has been given over here. So this monocrystalline type of the solar panel having the 72 numbers of the solar cell, it is a utility scale type of the solar project. We can just go for the solar panel. But smaller type of the solar home systems also, we can use one or two panels for the designing purpose over here. Or lesser than this capacity also, any manufacturer solar panel, we can easily choose over here actually. So let's say if we are going to choose this 340 watt peak of the solar panel, then first we have to just see that what is the peak power in terms of the watt actually. That is a watt peak power also we are measuring the corresponding solar panel. It means what? The solar irradiation data of 1000 watt per meter square, and whenever the standard test temperature is 25 degrees centigrade and air mass is 1.5, so in that cases in a laboratory every solar panel has getting tested over here actually for their standard output conditions. So 340 watt peak of a solar panel is giving us the maximum power point voltage, that is a VMPP voltage we are calling. It is a 38.2 volt. So this parameter we have to note down if we are going for this particular panel. Second is the maximum power rating or the maximum power current we can say in terms of the IMPP, in terms of ampere, it is 8.90. This we have to note down. Next, the open circuit voltage VOC 46.2 volt and the short circuit current IAC is the 9.50 ampere over here, and module efficiency in percentage is 17.5. So we have to note down the VMPP, IMPP, VOC, IAC and ETA of this particular or efficiency of this corresponding panel. So these 5 parameters are important whenever we do the further calculations in the corresponding designing of the solar home systems. The next parameter we have to see is the temperature coefficient rating over here. So basically whenever this temperature rating we are saying, and that to be the temperature coefficient we want over here. So in this corresponding solar panel, temperature coefficient at the open circuit voltage VOC is minus of 0.29 percentage per degree increase in the temperature over here, or per Kelvin increase in the temperature they have mentioned. So basically it means that whenever we are just sizing the string sizing inside the solar panel designing or energy yield estimation for power calculation in terms of kilowatt hour, so in that cases every 1 degree increase in the temperature beyond 25 degrees centigrade, there is a loss of voltage we are getting in the percentage of minus of 0.29 percentage. So that is why from the standard test temperature of 25 degrees centigrade, whatever the increase in the temperature is happening actually per degree increase in the temperature, there will be some kind of the loss has been happening in the voltage and the power production also from the solar panels actually. So that is why the temperature coefficient parameter for any solar panel we have to check it out over here, and then we can select the solar panels over here. So we just compare the different data sheets over here. We just find which data sheet will have a lesser number of the temperature coefficient over here. Simultaneously, what amount of the maximum voltage and the current we are getting, that is also matters over here, which seems that how much amount of the power could be extracted from the given amount of the solar panels over here. So once we have just noted down the temperature coefficient parameter over here, now we have to look at for the mechanical data actually. So basically in mechanical data, we have to focus on the first parameter, that is which kinds of solar cell has been used in the solar panel and what is the dimensions of the each solar cell. So in this case, it is a monocrystalline type of the solar cell and dimension is 156.75. Next is the cell orientation we require. That is how many number of solar cells we are using and how much solar cells are connected in the series combination. So in this case, it is a 72 number of solar cells they are using and 6 by 12. That is each row is carrying the 12 cells and there are total 6 number of rows are there and each row is been connected in series combination. So basically only the solar cells, which kinds of manufacturing technology the people are using and what is the numbers of solar cell they are using. So this also we must know whenever we choose the solar panel for home system design. Next is the module dimensions we required over here. So it means what is the lengthwise and widthwise, what is the basic dimensions of the solar panel is. So whenever we design the mounting structure for holding the solar panel over the rooftop area or any ground mounted area, so that time we must know what is the dimensions of the solar panel and what is the weight of the solar panel that we are using. So in this case, the weight is 26 kg and we have to just check it over here that what is the J box rating is there, what is the junction box will be there. It should be the IP67, which is the ingress protection or the outdoor protection also we can say at a rating of the 67 over here. So like that, this particular parameter we have to just note it down over here actually whenever we just read any kind of a data sheets of the solar panel, because by reading of the data sheet actually we are just getting the idea over here what amount of the power we can extract from the given solar panel, so that we just going for a design of the proper design procedure over here.